Hi, everyone.
Hello.
My camera is going to remain off because my connection is not the best.
Sure thing. Cool. Okay, so I'm going to assume there's not a demo. Skabek, do you want to talk us through how's the API service?
It's great. It's deployed into Canary. It is not currently taking any traffic. We have a configuration item that is missing. This was an object that was tossing a lot of errors in staging, so we had to prevent staging from taking traffic until we had some fixes in place. Unfortunately, the fix that I created was kind of misguided, and it took into account the use of geo. So this created a problem in production when we tried to roll it out. It created a situation where last week, this was first making a lot of requests to the API service, and they were getting stuck by rack attack. So due to that, we rolled the change backwards. Stan worked on a fix to modify the application code to resolve that. So that was fixed. And then we decided to roll that back into place again on, was it Tuesday? Yesterday? Yeah, Wednesday, yesterday. And then Andrew decided to show me a chart that said, oh, you're saturating our cloud NAT pool for just the registry nodes because we're making way too many connections back to our API fleet. And this is due to because the registry is making connections to the API for notifications for the geo service that we don't use in GitLab.com. So I worked with Jason a little bit at the very end of yesterday on a fix. That's the merge request, or that's the issue. There's a merge request associated with it. It's currently ready for review. But once that gets into place, that would relieve the workaround that we are using to get this configuration into place. And then we could start taking traffic in Canary. I hesitate to do that now simply because we'll have a situation where we'll be throwing a lot of errors because the registry and the API are not mending very well. This is a GitLab.com specific thing. We are using notification events as a way to monitor our container registry usage, the API. So this isn't something that customers would run into. This is something just the way that we decided to implement this particular feature of getting metric data in the snowplow. So we're almost there. So in the meantime, I finished up the readiness review yesterday, and I sent it off to 3 groups of people, a couple of SREs, Stan from development, and then a couple of members of security to have an overview of the readiness review to see what holes we have in our documentation and such. So I'll be following up on that information as the reviews come out from people. I've already got some information from Stan as well as the security team so far, so that's helpful. So yeah, it's just a matter of waiting for this fix to get reviewed, and then however long it takes to get merged into master, or if the review is taking too long, I'll just pull that in manually and go from there.
And we can definitely, did you add a priority label onto this review? Perfect, great.
Can someone leave a link, please?
I could do that, yeah.
How quickly do these errors show up? Like when we start sending traffic to Canary, how long does it take to see whether this issue's been fixed or not?
It's immediate, but I'll be using, when this gets merged and our Helm chart gets upgraded and pushed out through Canary, the only thing I'm going to be checking for is the configuration item existing inside of the GitLab YAML file. That's how I know that we're good to go. And as soon as that's done, I'll start working on the necessary items to start sending traffic, which in this case is just modifying the weight values of the canary environment in HA proxy. And then from
Nice.
there, it's just monitoring the canary service to make sure it's operating okay. Looking at logs, looking at metrics.
Super, great stuff. Nice. And then in terms of on Canary, so I chatted to Graham yesterday, and he is still working through the service discovery, sometimes fails inside Kubernetes blocker. So it's at the top, I'll just move it down. So he's hoping to have some experiments that we can run to try and progress this one further, like before we become blocked is basically the kind of goal. So as much as we can try and get this ahead of us wanting to move ahead of Canary. But at the moment, we are still a bit in the dark about what's going on with this one.
So about this, I would like to try to figure out if there's a way to determine how many requests we are making versus how many requests that are being shut down for whatever reason. But I don't know how to create the necessary charts to do that. So I was wondering, Andrew, if you might be able to help me out with this. Because we know how service discovery works. We ping console every 60 seconds. Every pod is going to do that every 60 seconds. I did leave some open questions in that issue related to this, but I would like to be able to figure out how many requests we are making, because we don't log the successes. We only log the times that we fail. So if we could figure out how often we are successfully making those requests, we could derive the ratio of how many times we fail to make the service discovery request. And then we could determine how often this is an actual problem for us. But I also have some open questions related to how service discovery works, because I don't know much about it, and I don't know who to ping to bring into it. But like, if service discovery fails once, what does the application do? For example, like, do we immediately try again, or do we just fail and start switching over to the primary server? Like, what's
right?
the
Are you talking specifically about the service discovery for finding a replica using the service record? So I'd need to confirm this, but I'm pretty sure that if it doesn't, in fact, I know that if it can't discover, it goes to the primary, because there's that other bug about Sidekick starting off with traffic only going to the primary, and then it fails, well, sort of fails over to using the replicas. So that's definitely how it works. But the way that service discovery works is not by pinging. It's
making a DNS request.
It's a service record.
Sorry, I was using the word ping. I was overusing that word.
So if I mean, I guess we could like put logging on somewhere on console to kind of log those requests, and then either just use grep and kind of hack it, or put it into structured logging. It's calling console on the local node, right? Is it a daemon set?
It's a daemon set, and as from what I could tell, it's going to go through the service. So that request is going to land on whatever pod is available, which, depending on the cluster, ranges between 30 and 80 plus nodes.
Oh, so it doesn't always go to the local node.
No, that's one of the options that Graham would like to explore, is modifying how those requests are handled.
Yeah, I mean, I haven't done a lot of this, but my initial reaction is that would be better, because just because that node, that agent can get to that secondary, right, doesn't mean that you can. So you going to somewhere else on the cluster and saying, you know, what can you see is available right now, and then you're using that, where you should rather be doing that locally, I would imagine.
Yep.
And it's less surprising as well.
Yeah, I agree.
I mean, that might be, I don't know offhand, but that might be part of the problem.
It is an option that Graham would like to explore. I haven't followed up with him on that particular item, but I'll have to read through this
Is
issue.
there
It's
an
been
issue for
a little
that?
bit.
Yeah.
I
Yes.
created an
Oh,
issue.
sorry, go ahead.
So I created an issue off of this one that basically is exploring the options for running the agent.
Yeah.
But I don't think we've touched this. So Graham has looked into this a little bit. So I'll have to reread through what he's written to figure out where we are.
Yeah, and yeah, just that's how we do it on VMs as well, because you going through service, you've got the service discovery to service discovery, which is kind of.
But isn't console having a consistent view, or it should have a consistent view, unless there's a partition, what is available and what not? I mean, they should agree.
The problem is not that console has differing or bad data. It's that sometimes we make a request to console and that request fails for X reason.
Yeah, I know.
Yeah, I suppose. Yeah, I mean,
locally it would be better because of performance and latencies,
Less
I guess.
Network, yeah.
But it shouldn't be inconsistent if you go to one or the other console node, right? From the result that you get, I hope at least.
Well, that was the problem we've been trying to figure out, whether it's due to a pod being rotated or maybe a node being taken out of rotation at just the right moment when a request is coming in. But so far, we've been unable to determine that. One of the things that Graham did find is that the Calico network service might be misbehaving on some of our nodes, and that would impact the ability to send traffic to the appropriate pod. But I just started my day, so I haven't read up on this issue yet.
Yeah, I just sort of like the idea of it seems less surprising to use the local one as well, like it's the principle of least surprise.
I would agree.
Yeah, but Henry, you're right. It should be consistent.
But like I said, we're seeing roughly 300 requests fail per day, and I feel like we would be making a lot more requests because we run roughly 300 pods that run all the web service information throughout the day anyways. So, assuming 300 pods times 60 times per hour that it's doing this, we're making a lot of requests and very few seem to be failing. But I would like to try to create a chart to prove how often this is, but I don't know if that's possible based on our current metric capabilities.
Cool. Okay. Anything else about the API service that we want to discuss?
I don't have anything.
Nope. Okay. So number 4, Andrew, lucky you, and thank you for helping us out with the observability stuff. I thought it might be useful to start off and just maybe get some thoughts around like where we are with this and what we'd like to ideally be seeing, so that we'd had some sort of initial work on the Epic. Those pieces were very much tied, I think, to where we were in the migration rather than being kind of the overall Kubernetes observability. So completely welcome to scrap this and put in a completely fresh load of stuff. But whilst we have everyone on the call, what do we want to do with observability?
So I haven't had a chance to look at the issue yet, but or the Epic, but in my mind, the things that I was thinking about are really important is having first-class monitoring for node pools as a thing that are kind of their own thing. And so they're going to be a little bit different because everything else that we have in our world is kind of in this service hierarchy. So, we have services and stages and shards and everything kind of rolls up to a service. And that was true in the VM world as well. We had each service was on a different type of node. And now the node pools are kind of mixed a little bit. So we get, some services have 2 node pools, some node pools are shared. Then we have the bug that we have some random jobs that are just kind of going anywhere in the Kubernetes cluster. And so there's it's a many-to-many between services and node pools. And so I think we should just monitor those as their own thing, with their own set of dashboards, like, how is the health of my node pools? So there's a kind of like a high level overview, and then you can go down into a single node pool and see the health of that. So that's the node pools. And then backing on the work that we've already done for monitoring, like I think we should just make sure that it's working properly everywhere. Like the other day we got plant UML fixed. We should make sure that that's there. We need to get the autoscalers into our monitoring so that we can see autoscaler saturation, and then, sorry, back on node pools, we also have node pool saturation. And then the, all of the graphs that we've got on those Kubernetes detail dashboards at the moment, there's a lot of places where we're just seeing like error, crash loop back off. Like a lot of pods fail for strange reasons, and we're not reporting on that at all at the moment. So we need like much better alerting around that. I don't know what you think about this, Skobik, but I was thinking that if we almost treat it like an SLO, like the number of pods that fail divided by the total number of pods that were created, or containers or whatever, because you don't want to kind of alert on a fixed threshold or on a like, oh, a single pod failed, there was an error, like, so we could use the current like SLI approach that we have and just apply that to like pod creation and failures in that, in the same way as like a 99.9% of them should, in a month, should be successful.
It would never
So that
be
was my
reasonable
thinking.
to report that a single pod is failed,
Yeah.
because there could be any number of reasons a pod fails. Like it could be running out of memory, or we could have killed it because we configured our project exporter or importer to, no, it is export, to make sure that's not using up too much disk. And if it picks up a job, it tries to write 30 gigs of data, we're going to kill that pod. So it'll be unreasonable for us to fire an alert or a page on something like that. So a ratio or that kind of makes sense.
And we also get, like, at the node pool level, like I've seen quite a few OOMs and kind of weird stuff that we're also not tracking at the moment, and we should probably, on those node pools, make sure that we, firstly monitoring load, and that issue that I linked there was that CPU scheduling one, which is like outrageously high, and we still don't understand why, but that stuff as well. But what about crash loop backoffs?
We'll want to know about that, because that could be
but pretty
problematic.
quick, right? Like that should never happen, right?
Precisely.
Yeah.
That's usually,
So
that would be a symptom of something else bad happening, whether it be a database issue, maybe a configuration issue.
Yeah. I mean, we should probably look, once we've got it going, we should probably look at seeing if we can put crash loop backoffs into the deployment health indicator, because it's probably the best deployment health indicator that we have.
Yeah.
Like, if there's a crash loop backoff, don't carry on deploying this thing.
Yeah, the same could be said for configuration changes as well, which we don't have integrated into the configuration management pipeline, but we probably should.
We probably should, yeah. Let's get this done.
What do you need for this, Andrew? Like, what's your kind of plan around kind of taking this epic and getting it to, I guess, like amazing monitoring?
So I'll appreciate reviewers and feedback, and I will start on like a grooming that epic and going through it, and then kind of mostly like reviewers, but then also like not just reviewers, because that just means but like feedback on how we're doing it, and we can get that going, get the alerts going properly for that as well. And then also, I think it'd probably be quicker if if we need more labeling done and that kind of stuff. Skobik, do you think we've got all the labeling now that we need on?
I hope so.
Yeah, because that was a drag.
If we're missing something, like, I could apologize, but I'll try to work on that as quickly as possible. But I'm hoping we have all the labels necessary, because that took a long time to get accomplished. So
it did, yeah. Okay, cool. So yeah, then mostly I guess it's just figuring out like if there's more labels that we need on anything, and getting all that done. And then, yeah, trying to figure out a plan for like, I guess, oh, yeah, like a plan for, are we just going to set up this Kubernetes service like that we've kind of spoken about a few times? Is that going to be, when we attribute like a node pool being saturated, because we try to do everything to the level of a service, is the service going to just be the kube service or k8s service or something like that?
That's a good question.
What are the options? I don't. So I know we talked about it, but I can't remember what we said last time.
So at the moment, because like of that sort of many-to-many issue with the, like we have many node pools to many services, although there is kind of a one-to-one on a lot of them, like, you know, ultimately what we're trying to do is get some sort of attribution and ownership on alerts, right? So when an alert comes in, you'll see nearly all of our alerts say it's the service. And then, you know, technically you could say, well, it's the data stores team's alert. But because a node pool doesn't have a service, we either need to kind of create a new service called like Kubernetes, and then I guess the ownership of that would be the delivery team. You know, or we do some sort of inference where we're like, oh, well, this node pool mostly serves this, but I think it's too complicated. Like, I think just having a Kubernetes service would be the best way.
But for having it attributed to services, still maybe can we have record rules that at least match it to certain services? So we have one Kubernetes service generally to watch what's happening there, right, for the different node pools. But to see this per service where we are in danger of reaching some limit, we could still maybe generate something so that we can include it in the service dashboards.
So for the for the HPAs, for example, those will definitely be attributed to a service. So if an HPA is maxed out, that won't be pinging the Kubernetes service, that'll be pinging like Git and saying, you know, we've got no more Git part or Sidekick or whatever. And so on an HPA, on a node pool, it will probably say Q. So if we, you know, if we kind of maxed out the node pool, then the alert will go to Kubernetes. I think from my point of view, I would imagine over time that we're going to get less and less node pools. And, you know, instead of having, you know, the node pools will just be kind of different types of machines. And so as we go towards that, you know, having these very rigid node pool per service is going to become more difficult.
I would agree with that.
Yeah,
I would agree with that because there's more than just what runs a specific service on a node pool, because you have the monitoring infrastructure, you have the logging infrastructure, etc.
That's totally true.
At some point in time in the future, we're going to come back and try to do a cost analysis on Kubernetes because we do spend quite a bit on our clusters.
Yeah.
And we're probably going to try to figure out how to do a cost analysis and resource analysis to figure out how we could lower that bill at some point in time in the future. So that makes sense to me.
There's a related kind of thing that I've noticed, and like the reason we had to go away from those 6-hour burn rates on Thanos was because, not because of the number of pods, but because the number of pods that started and stopped through the day. And I don't have any data on this yet, but like between like 9 a.m. in Europe and say 5 p.m. in Europe, right? I don't imagine that you're going to need to like recycle your entire fleet down because the traffic's just going to be getting higher and higher. So why do we see so many pods stopping and starting, even if there's no deployment during that time? And I think that there's also some sort of optimization around like when we're evicting pods and like it seems to be just way too high from my eye at the moment.
We definitely churn very high. And I think there's two ways we could go about adjusting this. Is one, modifying the way that we scale just on a different metric. That way we kind of slow the rate at which we change. The problem that introduces is if for whatever reason we suffer, say, an outage, or maybe there's just for whatever reason lower traffic, we'll be slower to scale upward during high demand. So I think it would be great if we had the ability to scale on a custom metric. That way we kind of leverage the ability to scale up and down based on some metric that we define. That way there's always pod availability and that we're not resource starved, and vice versa, we're not overutilizing anything. That would reduce our churn rate, because then now we have a smooth curve of pods starting and stopping throughout the day versus this jaggedness of starting and stopping pods constantly every 3 minutes. I think that would be a great optimization we could look forward to in the future.
So once we have custom Prometheus-based scaling metrics, we've got, this green area here.
That's precisely what I want to scale on, is that upper bound of that green line.
Exactly, and that's your baseline, right? So if you have a second metric, which then starts giving you a signal that you need even more, you can increase more, but then you never go down below that boundary over there. And we know how to do that now. We've got all the metrics, we've got all the detail, and then that would be your, and you advance it by like 10 or 15 minutes, so that by the time the load has got there, the machines are ready, or the nodes are ready to go, or the pods are ready to go.
Yep. I think the one thing that would be slightly different is Sidekick, just because that's going to be based on queue sizing, and that would change drastically throughout the day. But like our normal API fleet and the Git fleet, for example, that would be a perfect metric to utilize.
Yeah.
Custom metrics and scaling is something that's been on my bucket list. I would love to get to it at some point in time, but I think we need to finish migrating to Kubernetes too.
Yeah, and also we really need to understand our metrics and have all of our dashboards before we start using those metrics to scale, because otherwise we're gonna be in for a lot of pain.
Amy, back to your original question about this particular epic, something that I find missing, maybe it's somewhere else, but I know you had a conversation with Graham about our observability into Helm and deployments. We're missing some log data during a deployment operation. Is that in a different epic somewhere?
Yes, there's an issue for that, which Graham's going to put his thoughts on. So this is all about the thing he posted in Slack about Atomic, whether we should keep Atomic upgrades. So let me just find this. So yeah, he's thinking about this, and at the moment, I think it's quite likely that once we've done the API service migration, in the kind of weeks of tidy up after that, he'll take a look and see if this is a big job. So 4E is the issue that we'll go on to. So yeah, he is thinking about it. It's sort of in the sort of starting point was the Helm 3 logs, the fact we don't have the Helm 3, the logs now, we have Helm 3. But actually, I think he's thinking about this, whether this is slightly bigger, and whether actually this, the order of, or the way we do things in the pipelines actually related to this issue 721 is actually the right approach. So I don't know how big a thing that is. I don't quite know what the changes he wants to make in there, but yeah, certainly it was we need to get that observability back that we lost with Helm 3.
Yeah.
Perfect. Cool. So Andrew, feel free to just give us a shout, either in Slack or on the issues or in these demos, for if you need input or need help with any of this stuff.
I will definitely do that. Thank you.
Yes, thank you for taking this. So the final thing I was just curious about, this one can be a quick one because I know we have it written down as well, but I'm just really curious about the pre-deployment issue we had following the registry changes. Just I thought it might be just of interest and useful for other people to hear what, maybe not specifically why this one was a problem, but sort of more generally, what sort of problems did we see here, and do we need to do anything special to make sure we avoid these sorts of deployment problems?
So we did not have a problem with pre yet. This was something that was on my mind after we introduced the container registry, and it just took me too long to get an issue open for. But I was reminded of this when I hopped on Friday to tell everyone that I'm going to stay in bed, but I saw where Henry was troubleshooting with Yorick the fact that after I'd introduced the API into Canary, I was blocking deploys because we were introducing a change, or we were trying to deploy to Canary, but I didn't update our checking mechanism to say it's okay that there's a change to the API deployment. So because of that, that reminded me of this. The situation would be that when we execute a pre-deployment, because something other than an image change happens on a specific set of jobs or deployment objects, the checker would fail because it thinks there's going to be a configuration change sneaking into place. Like, this is a protection to prevent us from having accidental changes make their way into our clusters during a deployment. So since the container registry is spinning up a job and destroying a job for every single time it deploys, this is going to cause a problem when we deploy the next release candidate to pre. So I fixed that.
Yeah, I mean, the ugly thing here is that for our DB migrations and Kubernetes and for registry, we spin up a job instead of spinning up an init container. And a job will always be a new object. So it's always seen in the diff, which each deploy we will see a new diff just for creating a new job, which is expected, but it's not nice because it'd be nicer to just see a diff with no change if we just, run the usual DB migrations. So if it would be implemented as an init container application instead of a job, I guess we would not see any diff, and then we wouldn't have this issue. But I'm not sure of the complexities for other use cases than for self-service customers and things. It's a little bit tricky, I think.
The problem with doing an init container is that it's going to get run for every single pod. So if we're running 80 pods in production, for example, because I have no clue what we do run today, you're going to run that migration script 80 times, which is not reasonable. So it makes sense that it's configured as a job, and that's exactly how our migrations would work if we were using them inside of our Helm chart for our Rails application, but we have that disabled because we run migrations as part of a deployment process that we define.
Yeah, so filtering out this specific diff probably is the best solution here. And this is done now.
So Amy, does that answer your question?
I think it does, yes. Is there anything we need to do in the future? Like, are there any kind of, I guess, like things we need to watch for, anything we can make easier in the future so that we can avoid these things? I appreciate it's relatively low risk because we don't have deploy to pre very often, but even so.
I think we need to remember when we add new services to Kubernetes that we need to also adjust this filter that we have. So each time when we add something new, like if we add Canary to API Canary or API gprod later, we need to adjust this filter to also include this diff to be filtered. See, we shouldn't forget about this. So this is still manual.
Yeah. Luckily, it's an easy fix. It's so very quick. It's just unfortunate that I completely forgot about it.
Do we already have like a checklist or something that reminds us of, like, when we add a new service to Kubernetes, we need to do these various things?
I mean, it's mentioned in the README of the repository, but you don't read this every time when you do a change, right? So we don't have an explicit checklist like this.
Okay. I wonder if that might be useful. We don't have to do it as a corrective action now, but like, I wonder as we go forwards, like as we get more services coming into k8s and like if other teams start adding them as well, whether that might be useful.
Yeah, I mean, it's some kind of tribal knowledge, I think. I mean, I know that, I think Skarbek explained this to me at the beginning and I forgot about it again. And then I wondered when this happened, oh, where's this coming from? Why is it complaining? And then Jav reminded me again, oh, we have this filter. And right, there was this one thing. I mean, we don't do this very often, right? That we add new services. So for several months, nothing will happen. And then you do this and then it pops up again. So it's not hard to fix, but it's still something which you need to think about. Yeah.
Yeah. Okay. Well, maybe we should. I'll open an issue. I think we should probably start thinking about like what are the things that when we add a new service to Kubernetes, we want to make sure we've always updated or checked, so that we don't have to try and remember all of these individual pieces. Awesome. Thanks for going through that though. Is there anything else that anyone would like to talk about today? No? Okay. Skarbek, you said this would be super quick, and it wasn't, and it was excellent. It was a great discussion. So thanks everyone for coming along today, and good luck, Skarbek, with the next step of Canary. Awesome. Thanks everyone. Have a good rest of your day.
Bye.